Hi all, I am Shalu Rose, Assistant Professor in Triple Department from Mrs.Shalu College of Engineering. Now I explain about PN junction diode. This PN junction diode will be formed by the P-type and N-type semiconductor material. So first we have to study about P-type and N-type semiconducting material. In N-type semiconducting material, when extra valence electrons are introduced into material such as silicon and n-type material is produced. The extra valence electrons are introduced by putting the impurities or dopant into silicon. The dopant used to create the n-type material or group B material. The most commonly used dopant form of group B material is arsenic, antimony and phosphorus. The 2D diagram of the left shows the extra electrons that will be present when a B group dopant is introduced to a material such as silicon. This extra electron is very mobile. Next one is p-type material. In p-type material is produced when the dopant that is introduced from the group 3. The group 3 element have only 3 valence electrons and therefore there is an electron missing. This create the hole or positive charge that can move around the material. Commonly used group 3 dopant are the aluminum, boron and gallium. The 2D diagram of the to the left shows the hole that will be present in the when group 3 dopant is introduced to a material such as silicon. This hole is quite mobile to the in the same way the extra electrons in the mobile in the n-type material. Next we have to study about p-type p-n junction. Here the p-type material and n-type material will be formed when steady state. The no external source will connected to the p-n junction diffusion and balance each other out for the both the holes and electrons. The space charge region also called as the deflection region. This region introduce the positively and negatively charged ions. The space charge regions do not have any free carriers. The width of the space charge region is denoted by the W in a pure formulas. Meteorological junction, it is a interface where the P plus P minus and N type materials will be meet. Na and Nd, here they represent the amount of negative and positive doping in number of carriers per centimeter cubed, usually in the range of 10 power 15 to 10 power 20. Next one is bias in the PN junction. The PN junction is considered bias when the external voltage is applied. There are two types of biasing. First one is forward bias and second one is reverse bias. Forward bias. In forward bias, the deflection region strings slightly in width. With this stringing, the energy required for charge carriers to cross the deflection region decrease exponentially. Therefore, as applied voltage increase, currents start to flow across the junction. The barrier potential of the diode is the voltage at which appreciable current starts to flow through the diode. The barrier potential varies for different materials. Reverse bias. Under the reverse bias condition, the deflection region widens. This causes the electric field produced by the ions to cancel out the various reverse bias voltage. The small leakage current is that is IS, saturation current flow in the under reverse bias condition. The saturation current is made up of the electron hole pair being produced in the deflection region. Saturation current is sometimes referred as the scale current because it is relationship to junction temperature. Next one, it is the PN junction diode characteristics curve. Here we have to draw the drain current and drain voltage. That means VD means bias voltage, ID means current through the diode. ID is negative for reverse bias and ID is positive for the forward bias. IS is the saturation current, VBR is the break-on voltage, V5 is the barrier potential voltage. Next, properties of diodes. First one is Schottky equation. The transconductance curve on the previous slide is characterized by the following equation. IDC is equal to IS into e power VD divided by eta VT minus 1. As described in the last slide, ID is the current through the diode, IS is the saturation current, and VD is the applied biasing voltage. VD is the thermal equivalent voltage and is approximately 26 MV at room temperature. This equation find the VT is the various temperature. Then types of diodes and their uses. First one is PN junction diode are used in the allow current to flow in the only one direction, while blocking current will be flow in the opposite direction. The p-n junction diode is a typical diode that has been in the previous circuits. Here it will be formed by the p-type and n-type semiconducting material. Then Senna diode is designed as to operate on the reverse breakdown condition. These diodes have the very accurate and specific reverse breakdown voltage. Next one is LED, that means light emitting diode. The light emitting diode are designed with a very large band gap, so movement of carriers are across their depletion region emits photons light energy. Lower band gap LED, that means LED emit the infrared radiation, while LEDs with higher band gap emit visible light. Many stop lights are now starting to use LED because they are extremely bright and last longer than regular bulbs for their relative low cost. Next one is photodiode. So photo LEDs emit light, while LED light emit, photodiodes are sensitive to receive light. They are constructed to their p-n junction can be exposed to outside through a clear window or lens. In photokinetic mode, the saturation current increases in proportion to the intensity of the received light. This type of diode is used in CD players. Then photovoltaic mode, when the p-n junction is exposed to a certain wavelength of light, the diode generate the voltage and can be used as an energy source. This type of diode is used in the protection of the solar panel. Thank you.